Okay, sir.
Madam, whether the screen is visible?
Yes, sir. Your screen is visible, sir.
Thank you, madam. The audibility?
Yes, sir. It's also clear.
Yes, ma'am.
So we'll wait for actually 26 people are inside, sir. We'll wait for 5 more minutes and we'll start, sir.
Okay, ma'am.
Okay, sir. Sir Ramkumar sir.
Hello. Madam,
Ramkumar sir.
yes, madam. Is it audible, ma'am?
Ramkumar sir.
Is it audible? Is it audible?
Yes, sir.
Madam, is it audible?
Yes, sir. It's audible.
Ramkumar sir. Shall we start, sir?
Hello.
Sir, you are not audible, sir, actually.
Hello. Madam, is it audible now? Hello. Madam, is it audible now?
Yes, sir. It's audible now.
Yes, ma'am.
So, shall we start?
Sure, madam. From my side, okay, madam.
Okay, sir. A brand new good morning to everyone present online. Welcome to AST sponsored online short-term training program series 2 day 2 session 1 on IoT building blocks, protocols and technologies, security and challenges. I feel extremely honored to introduce our resource person of the session, Dr. R.P. Ramkumar, Professor, Department of Computer Science and Engineering, Mallareddy Engineering College, Secunderabad. He completed his graduation in computer science engineering at Karuna Institute of Technology in 1999. He then completed his master's in computer science engineering at Mahindra Engineering College in 2007, followed by his doctorate at Anna University, Chennai in 2015. He has a multifaceted experience of over 16 plus years in teaching sector and about 2 years in industry. And he completed an IBM academic certificate exam for Data Scientist Mastery Award for educators. And he completed a course of study on DLI platform course instructor offered by Deep Learning Institute NVIDIA in association with Bennett University. He completed a certified program on image classification, object detection, and neural network deployment with digits in NVDIA DLI association with Bennett University. He had published 3 books and have filed 2 patents so far. He also published his work in various national and international journals. He is a professional member of LMCSI, LMI, STE, MIEEE. It's a great privilege to have such wonderful, energetic, and eminent personality with us today. We feel honored by your presence, sir. On behalf of BCET and Department of Computer Science Engineering, we once again welcome you, sir. Now let us invite our resource person of the session, Dr. R.P. Ramkumar, sir, to move the session forward.
Thank you, madam. Thank you for the intro.
Thank you, sir.
Yes, madam. Shall I start, ma'am? Proceed?
Yes, sir.
Yeah. Welcome to AICT sponsored short-term training program on Internet of Things with blockchain applications and challenges. In that, the day 2, the topic what we are going to discuss is IoT. In that, building blocks of IoT, protocols, technologies, security and challenges that has which has major impact on building the IoT based applications. In this juncture, I would like to thank VCET, ACT, and our college, the Mallareddy Engineering College, for granting this option for me to present on day 2 session about IoT's building blocks, protocols, and technology, security, and challenges. Right? Just an intro. Mainly, in the what else, the way in which we are go through or we are going to have look at is first we will see the building blocks of IoT, as said in the title itself. As said in the title, things of IoT we will be discussing later. What else the protocols that deals with or with that concerns with IoT, right? Then the security challenges mainly if you are interested to go with the research activities with respect to IoT, then the securities and challenges we need to concentrate on it. Then for backtracking, that becomes much easier for us to proceed. Coming back to the introduction of IoT, in short we call it as IoT, whereas the expansion is Internet of Things, and its expansion is Internet of Everything, the advanced thing. What else we are going to see in the forthcoming slides, right? What is the way in which we can define Internet of Things? It is an emerging technology that enables the connectivity of devices. Either it might be through wired or wireless, right? That where through which we can able to communicate. We mean here the human able to communicate with the machines. The communication might be wired or wireless, right? This is first coined by Kevin Ashton. That is, the term Internet of Things is coined by Kevin Ashton in 1999, right? UK, right? The key attributes, the 5 key attributes of IoT devised by Goldman Sachs is acronymed as SENSE, SENSE, SENSE framework. For easier understanding, it was kept named as SENSE framework. The each letter in the SENSE word represents that. S stands for sensing, E stands for efficient, and N stands for network, and S stands for specialized, and E stands for everywhere. Coming back to the individual words, sensing, leveraging the sensor to generate contextual data. That means we are deploying the sensor based on our requirements. We are deploying the sensor based on our requirement to collect the data. That's what the first letter S represents. Coming back to the second letter E means efficient. That is, efficiently enhances efficiency in productivity terms by adding intelligence to the things. That is, through intelligence, we are going on getting the data. That means collecting the data, we are applying the intelligence for getting more insight onto it or getting more awareness about it. Network creates a network of things. That is, not only from one sensor, we are going to collectively get the data. That's what through the network. Right. Coming to the fourth letter, S, that is specialized. First S stands for sensing, and the fourth S stands for specialized. Ultimate use is focused on domain-based specialized offerings based on our requirements, based on our scenario, or based on the requirements. We will be deploying the sensors to collect the data. That's what the specialized environment represents. Coming to the next letter, E, the last letter E, everywhere. That's what we can able to deploy these sensors based on our requirement. There is no any restriction such that this is the scenario where this IoT cannot be deployed. Like machine learning algorithms, right? Very recently, the upcoming technologies or most of the environment where else we are going on seeing now the machine learning is being applied. Likewise, even the Internet of Things, there is no any place stating that this IoT cannot be deployed. Coming back to the definition again, the acronym SENSE, the 5 key attributes of IoT coined by Goldman, that is SENSE, sensing, efficient, networked, specialized, and everywhere. Here, I would like to represent one more point here. That is, wherever the data I am going on collecting it, for easier understanding, to avoid copyright issues, in the last line or the bottom of the current concern slide itself, I have specified the references from where it is being cited. Right? Last line, after 5, if you are seeing, see here, that's what in order to avoid the copyright issues, I would like to represent the concern point where it is being referred or the citation is even there in the concern slide itself for your understanding. Right? The history of IoT. During 1830s, the invention of telegraph was there, whereas the second half of the 19th century, the first M to M applications. Here, M machine. The machine-to-machine communication started in the second half of the 19th century. Then 1920s, Nikola predicts the smart devices, the way in which the devices can be communicated in a very smart manner or smart way. Right? During 1980s, vending machine as first smart device ever was introduced. Vending machines, for example, in foreign countries, will be going on representing just if you are paying or just spitting the card, or if you are dropping a coin, requestingly will be getting the items what we are interested. Likewise, like as of now in India, we have very few cities we have, whereas very simple example is ATM. will be firing and we will be getting the money, right? Likewise, what else the equipment or what else items we are in need of, the same thing we can get it. That's what we said to be as vending machines. Whereas in 1990s, John Roque makes the first toast via internet. So through internet, we can able to order or through can able to instruct the machine such that it bakes the toast for us or the breads. Right. In 1999, Kevin Nashon proposes WWW in short, as the expansion for WWW is World Wide Web during 1999. Whereas 2008, the number of IoT devices exceeds the world population. Whereas to 2020, it was estimated that IoT devices, number of IoT devices connected would reach 30.3 billion. Now even we crossed beyond this. Right? The evolution of IoT. The evolution of IoT. If you want to categorize it, see here nearly around, that is Internet of Things, the last column, the green, what is where currently we are going on discussing. Prior to that, if we are going back here, 1, 2, 3, 4 phases are there. Pre-internet, that is before the internet usages, what we will be having is we will be communicating to human alone, human to human communication, fixed and mobile telephony, SMS was there, right? Now, if you are going for adding smart network, that is just we are adding a smartness to the network, then it becomes Internet of Contents. Internet of Content, that becomes WWW, where through email, information, and entertainment was added. Again, we are going to add some more services, some more platforms to the current smartness, that is Internet of Content. If you are adding few more smartness to it, then it becomes Internet of Services. Where comes into the picture e-productivity, e-commerce, we call it as Web 2.0, right? We are going for adding few more smartness to it, such that the much more applications come into the picture for this role, so that there comes into the picture the social media called as Internet of People, where people directly communicates with the internet through these kind of various kinds of applications such as Skype, Facebook, YouTube. Again, now we are going to add the smartness to the devices and also as well as object. Then comes into the picture the machine-to-machine communication. That's what we call it as Internet of Things. Internet of Things, that is identification, tracking, monitoring, metering, automation, actuation, payments. That's what, see here, when we are going to the stage called as pre-internet, where human-to-human communication alone is possible, whereas through this Internet of Things, machine-to-machine communication, where going on adding smartness to the machine such that it can act by itself based on the existing instructions or based on the previous data or based on the previous history of the instructions what is being given to the machine or to the system or the object to the device based on the existing data. That's what we call it as machine-to-machine communication. That's what is being termed as Internet of Things, or even most of the authors, even they are going on representing the terminology Internet of Things as Internet of Everything, IOE. Right here, what we are going on in platform we want to present is smartness plus data and ambient context. This is the evolution of IoT. The roadmap of IoT. Roadmap of IoT. The same thing. What else we seen in the last slide? Just we are representing in the timeline. That is, in 2010, it was the internet or else the applications of domain. It was with respect to the home and personal use alone. What for we are using means the global addressing scheme such as IPv6, standardized interoperability, low power and thin batteries, cloud storage, and secure RFID. Where it is being used exclusively means smart sensors in healthcare, then data centers and WSN testbeds. The home and personal is being represented in red color. That is, the second half of the red color box shows that where it is being deployed or the applications of those environments in a specialized domains. Whereas coming to the 2015, earlier case 2010, it was with respect to the home and personal use alone. It was with the home and personal use alone. Home and personal use alone. Whereas coming to the enterprise, here RFID in retail, industrial ecosystems, low cost and SCADA systems. Whereas coming to 2020, in between the 2015 to 2020, that is from home and personal, it was used or it propagated to enterprise. From enterprise, it propagated to utility, where see here the critical infrastructure monitoring, smart grid and household metering, its application extended or made a footprint into wide domains such that large-scale wireless sensor networks, highly enhanced security, self-adaptive systems, cloud storage. That too, mainly when you are moving from local storage to the cloud storage, there is no any limitation at all, and the two we can able to retrieve the data based on the requirement, and the two with much more security. That's the major advantage with respect to cloud storage, even moving from home to utilities. And then next to that, the transport, plug and play smart objects, where comes into the picture the smart city. The major advantage with respect to the smart cities is smart traffic, automatically driven vehicles, autonomous vehicles. There comes into the picture major, that's IoT and also as well as blockchain technologies. Right? Then intelligent transport systems and the logistics. These are the roadmap of IoT from the local or the home system to the plug and play objects. Yeah, IoT is complex ecosystem. Yes, will be seeing that, or when you are coming to the definition of IoT, bluntly we can say that in one line stating that connect machine to machine communication, or even the things being acting as a smart system. Whereas if you are looking into the deep dive, or if you are taking a deep dive into the concepts, how it is being working, or it's the ecosystems, it is much more complex, such that to provide the interoperability between the machines, such that it provides the interoperability between the protocols, between the machines, between the users, and between the objects. That's what the major component we need to see it, or we need to concentrate on. The leftmost thing is users, groups, and communities all are acting on via an application, software, and technology on the right hand side. This user groups and communities, which is on the left hand side, works with the application, software, and technologies on the right hand side. These two are being interfaced through the three components named as sensing, embedded processing, and also as well as connectivity. Sensing means the sensors based on our environment, as already stated: temperature, gyroscope, and pressure. Temperature means which is used to ensure the temperature. For example, if you are going for agriculture, then we need to ensure the temperature. If the temperature goes beyond certain level, then we need to water the plant frequently. Whenever there is no any moisture at all, we will be going on ensuring the moisture that surroundings or the environment. If it goes beyond certain level, then we need to go for watering it. Gyroscope, the movement, what is the way in which the movement is being made. Based on the movement, we need to go for representing some activities. Say, call it, for example, if you are moving the mobile phones now, accordingly, or swiping it, accordingly the lights are being on, or the camera is being switched on or off, accordingly, vice versa. Right? Then the pressure, whenever it goes beyond a certain level, then accordingly we need to ensure that this either the object has to be stopped, or the device has to be stopped or off. For a very best example is that now whenever the persons are entering into the home or inside a particular room, the lights and fans are being on, or else the lights and ACs are being on, and based on the environment and the number of persons, the AC's capacity is being increased slightly, either to the 110 or 1.5 or even 2 times. Now, even in the advertisements we might be seeing now. So these are the environments where the sensing plays a major role. Coming to the embedded processing, that is hybrid network processor, where the data is being shared across the networks, then in which way it is being connected, either through GPS or Wi-Fi or RFID. These are the various ways. That is user groups and communities on the left hand side. That is the general, in case it represents the users. All the users together, they will be working with the application, software, or technology. These two are integrated with or interfaced with the components such as sensors, processing, embedded processing, and also as well as connectivity. The explanation for this, the same. What else we have represented now? That is sensing, embedded processing, or connectivity. Sensing, embedding, processing, or connectivity, the interfacing part. The next one is smart devices and environment, cloud computing, big data, the smart devices. Right? Then technology, software, and applications. Technology, software, and applications. Technology, software, and applications. Environment, cloud computing, the big data is the smart, the where in which the users groups and the application is being targeted. Right? Then the decision frameworks, IoT decision framework. That means it's all about how, where you are deploying, or where it is being used. Right? Through this decision framework, or the decision frameworks helps us to understand the areas where we are using it, and such that apart from using it, we need to make some decisions. Based on the decisions, how to make some functionalities, or what is the way in which you will be getting insight about the data. To be frankly said, this decision framework is used to have insight on a particular data. That's it, right? What else the decision frameworks components are available? That is, there are 5 different layers. There are 5 different layers from left to right. From left, if you are seeing this diagram, IoT stack technology, it is hardware device, then device software, then third is communication, fourth one is cloud, and the fifth one is cloud applications. Coming back to the one very basic example, I'll tell you this IoT stack technology. If I'm going for agricultural monitoring through IoT, then what we need to do, just we need to fix a sensor. Say call it as humidity sensor or else water sensor. We are fixing it, right? I'm having 1 acre of land, and through 1 acre for every 100 meters, I'm going for fixing one sensor. So likewise, accordingly, I'm going on for fixing the sensors throughout my field, and this is what's said to be as a device hardware. From the device, all the devices are being connected, communicated, and such that we are going on monitoring through the software. Whenever the certain level, whenever the concern, whenever the concern sensor reaches a threshold value will be knowing it, right? Threshold value means whenever we are fixing a data, and for example, the temperature, it goes below a certain X level or X degrees, so you need to initiate the watering to the plants. So these are controlled by a software. That means everything is being monitored by a software, and those sensors are being communicated, and all the data is being stored in the cloud, so that irrespective of the platform or irrespective of the location, I can able to access the data. After the storing it in the cloud, we are monitoring and getting insights, and not only monitoring, metered and controlled through the cloud-based applications. These are the 5 different layers which constitutes the IoT decision framework, right? And wherever we are using it, these 5 different layers of decision frameworks is required. For example, coming back to the second next slide, that is decision areas and its frameworks. Where the IoT is being deployed, wherever it is being deployed, these 5 different layers of decision framework has to be monitored. Say, for example, these are the different areas where IoT can be deployed. See here, the IoT decision framework pays attention to 6 key decision areas of any IoT product. Whatever the IoT product or wherever you are deploying IoT, those comes under 6 domains. That is, first and foremost thing is user experience. In short, it is said to be as UX. Right? The second one is the data. The third one is business. Fourth one, technology. Fifth, security. And the last, standards and regulations. Seeing the diagram here, for easier comparison, this IoT 5 different areas, 5 different layers, 5 different layers. That is device, hardware, device, software, communication, cloud, and also as well as cloud applications. All these 5 different areas are being categorized into 6 decision areas, 6 key decision areas. For example, with respect to user experience means it should satisfy all the levels. That is, it should satisfy the device hardware, device software, communication, cloud, and cloud applications. Right? These are the explanations for it, decision areas and its frameworks. Coming to the working principle of IoT. How it works. First and foremost, as of now, we are going on seeing the very best example of agriculture. Right? The same thing we will be deploying it. But prior to that, just I'll have an overview of how the IoT it works, the working principle behind the IoT. First and foremost thing is hardware. Actually, there are 6 levels. Even few of the books, if you are seeing, either in the books or the authors or in most of the vendors also, they will be having their own working principles, but general working principle behind IoT. Here in this diagram is getting categorized into 6 levels. The first and foremost level is hardware, right? How you will capture the data, in what else the way in which you will be capturing the data, right? That is, it comprises of devices, sensors, and actuators. For example, temperature sensor, pressure sensor, light sensor, or amplitude sensor, etc. That is, how will you capture the data? How will you capture the data? This is point number 1. Point number 2 is connectivity. After capturing the data, how will you connect to the internet for sharing? That means user connectivity or protocol based on the environment. Either it might be the Ethernet or Wi-Fi or cellular or Zigbee or even low radius WANs, right? First and foremost is hardware. Then after collecting the data, it has to be shipped or it has to be communicated. Then after communication, that's what, where to send or how, what else the way in which it can be shared is sending the data. How will you get your sensor data from the device to cloud? That is connectivity we can able to share. To some extent, we can share locally. If you want to share to the cloud, what is the procedure or how you will be sharing the data or collected data to the cloud? That is connect devices to cloud with over 50 plus firmware libraries. Once it is being stored in the cloud means it is very easy for us to get the insight about the data by all ways, by all means, right? Through either HTTP or MQTT, UDP and TCP, right? MQTT stands for message queue telemetry transport, right? HTTP hypertext transfer protocol, user datagram protocol, and TCP transmission control protocol. Coming to the storage, how will you store and manage your device's data? You should have only one copy of it, and the two for you need to have even the backup of it. Whenever you are having a problem with the original data, that backup data has to be supported. That is point number one. Point number two, even though you are going for distributed data, if even there is a update in one location, that has to be recorded in all the locations. That has to be ensured. That is optimal time series backup or backends. Storage, manage, and recall devices and variable data with minimal latency. That means latency means the time elapsed between the request and the response. If you are going on requesting the data and it has to be processed based on the requirements, right? Just I am in need of a very urgent data. If it should be processed at the earliest to my requirements. If I am, for example, if I am requesting the data at morning 10 o'clock and if the data is submitted at 11 o'clock, then no other requirement is there at 11 o'clock. That's what, right? With minimal latency is very, very, very important. That is, storing alone is not a problem. Storing and retrieving the data based on the requirement. Right? For example, not only for agriculture. For example, with respect to agriculture, if you are delaying the watering for plants by 1 hour, doesn't make much more problem or much more no issues, right? Whereas delaying it for half a day, somehow it is. Whereas delaying it for 1 day based on the plant scenario or the plant situation, then it becomes much more serious. Or delaying it for 2 to 3 days, then it becomes much more issues. For with respect to agriculture, somehow for 1 hour we can 1 or 2 hours, somehow we can expect the delay. Whereas the same application, if you are deploying for operation or whenever there is a very critical situation with respect to the patient, then delaying of 1 minute itself puts the patient's life in trouble. So based on the scenarios, based on the environment, we need to look into the fact. And coming to the visualization, how will you transform raw data into insights? Visualization, that means how will you transform raw data into insights? That is, make sense of your data with visualization and alerts. That is, displaying charts, the tables, maps, metrics. That the same data, instead of going for just an explanation, what is the way in which you can able to represent the data so that we can have a clear idea about the existing data, such that we can have or we can go for subsequent functionalities or subsequent processing. The last one is design and users management. How will you distribute your data and insights? How will you distribute your data and insights? That is customized user access, logos, colors, icons, permissions, and more. That means the end user, what else the way in which after going on collecting the data that is from hardware, has to be shared, connectivity, where to connect or where to share, store. For storing the data in the cloud, I need to share the data to the cloud. So that is third one is sending data. The fourth one is storage. After storing without latency, I need to retrieve. Then after that, I'm going for getting the insight on the data, such that exploration of data makes me much more happier, such that I can go for subsequent processing at last, design and users management, such that we will be going for more utmost insight into the data, such that we'll be taking actions and implementing it. The general structure of three-layered architecture. Why it was represented as three-layer architecture means there is no any restriction such that IoT should have 3 layers of architecture. That's why it's being represented as three-layer architecture. Right? There is no any criteria, or there is no any specialized statement such that IoT should have only the 3-layer architecture. Even you can go 4, 5, 6, 7 based on the requirement. Even there are much more higher end applications. They have 8-layer architecture also there. Few architectures we will be seeing in the forthcoming slides. Right? It is basically it is divided into 3 types, 3 levels in the layer architecture, or either level or layer also we can represent. The first and foremost is perception, where the data is being collected. The second one is network. The collected data has to be shared, and the application where it is being deployed. Right? I repeat, there are these are the very basic 3-layer architecture of IoT. The first layer is perception, second layer is network, and third layer is application. Perception is the area or the layer where the data is being collected, and the network for sharing the data, as the application where the collected data is being deployed. Right? Coming back to this, the functional area altogether, the functional area IoT's architecture is being categorized into 4 major components. 4 major components. What else we have seen earlier? It is being categorized into 4 major components. First and foremost is sensor or actuator. The second is device. The third one is gateway, and the fourth one is cloud. Coming back to the first one, that is sensor actuators, where the data is being gathered, or the where the data is being generated, right? And it is being communicated to the concerned device. From the device, it is communicated through the gateway to the nearby networks. From the nearby networks, it is being shared, or it is being communicated to the cloud for storage and also for getting the insight about it. That is, all the functional areas and their solutions are majorly categorized into 4 components, right? The explanation for this. Coming back to the stages of IT solutions architecture, right now we saw it, right? The first most category is sensors and actuators. The second example is internet gateways. The third one is edge IT analytics, where it is being more processing is being carried out. The last one is data center and cloud, where the data is being stored. Coming back to this, see the if you are going for seeing the last line or bottom of the image, where it shows that analytics management control, all analytic management control resides in all the levels. That is, the data flow will be in the left to right, whereas the control flow is from right to left. Whereas if you are seeing the stage 1, where much more hardware components are there, stage 2, through the gateways it is being communicated, where stage 3 it is communicated to cloud, where with respect to much more distances, either through Wi-Fi or cellular, either 2G, 3G, 4G, or even Wi-Fi devices. Whereas stage 4, it stores the data into the cloud for further storage, so that we can get more insights about it. Whereas coming to the first line, see here, above the stage 1, stage 2, stage 3, stage 4, or all the stages are covered with the security. End-to-end encryption is there. Then ecosystem, open, extensive drivers are there. As the last one is services, that means that transforms the data operational manager such that the security ecosystem and services are provided in all the stages: stage 1, stage 2, stage 3, and stage 4. Right? Coming to the potential applications of IoT, as already we stated, there is no any scenario such that IoT cannot be deployed. There is no any scenario such that IoT cannot be deployed. That is smart cities, connected cars, smart healthcare, smart retails, smart traffic systems, and smart factories. Right? Time plan or the smartness. As we are going on saying that IoT, right? Whereas what it deals with or what it has. Whereas during 2010, what else the number of devices are connected to each other, that is in billions, around somewhere around, it was predicted that world population is being represented in the horizontal line, whereas the number of devices are being represented in blue line. Right? It grows exponentially, not linearly. It goes exponentially, such that you can see that world population by the expected, it was around 2010, 15, and 20 was around 6.8, 7.2, and 7.6 billions, whereas the number of devices connected to each other in billions was around 12.5, 25, and 50. You just see that how it grows. Earlier, actually in 2020, it was predicted that 30 billion will be the devices connected, whereas it goes beyond double the times, that is 50 billion devices were connected. Whereas coming to the smartness with respect to IoT, the right side of the image, where anytime connection, that is on the move, outdoors and indoors, and daytime and nighttime, that is 24/7. There's no any restriction such that the device cannot be connected. It's coming to the place where it is being connected, either on the move, outdoors, indoors, and even at the systems. Whereas coming to the what else the things I can able to connect either between PCs, human to human to things, and things to things. That's what in the extension of IoT is being categorized as IoE, Internet of Everything, right? The building blocks of IoT, the building blocks of IoT. That is coming. If you are going for devising the applications here, anything, any device, anyone, anybody else, on any services or any business, on any path, and any networks, whereas any place, everywhere, there is no any restriction to the places or a restriction to the timings and restriction to the devices. That's why it was even termed as Internet of Everything, anytime, any context. Now, if I want to go for these sort of features or functionalities, then what else the components of IoT should have? That is things, the devices, for communication, the gateways, for better gateways, or to go with interoperabilities, then network infrastructure should be strong or should be robust, such that all the collected data should be stored, and for better usage of further processing, it has to be stored in the cloud infrastructure, right? The building blocks, right? What is the thing we are discussing now? IoT, every object is identified as nodes in IoT. Every object is identified as nodes and are connected to each other via networks. Okay. To make it much more clear, objects in the real world system are equipped with sensing elements, either the microcontrollers or the communication elements or the information storage and retrieval facility. And these all the objects in the real time are sharing the data through a specialized interoperable or else to shareable protocols. That means if there is no any restriction, for example, very best example I'll tell you. We are going for so in our PC, whereas most of the laptops are having inbuilt webcams, right? Whereas coming to the PC, it won't have a webcams. Just we are going for the market either through Amazon or else even you are getting any of the webcam directly. Nowadays webcam comes with the USB port, right? Webcam you are fixing it directly. After fixing webcam, you're directly connecting the friend to the USB of the CPU. Directly it starts working it, right? That means irrespective of the company, irrespective of the model, irrespective of the pricing, it has to work. That means the interoperable, either it might be the OS, Windows OS, or Linux, or even the concern OSs you are looking for. It has to operate irrespective of the OS and irrespective of the models, right? That's what we said to be as a corresponding opt protocol for all the one example I said. Likewise, all the sensors, what else we are applying it or employing it for IoT should work, right? This allows to have seamless and actively communicated information network, which is very strong and integrated on each object and IoT systems. Again, these four, what else we have seen here? Things, gateways, network infrastructure, in short we call it as NI, and cloud infrastructure we call it as CI. The forthcoming slide, right? Things are the concentrated areas where information is sensed with the sensor, whereas the gateways, which is used to share the data between the devices, as network infrastructure, it used to share between the networks. That is, blocks helps in control over information, allows secure and between the networks of different infrastructures, whereas the cloud infrastructure equipped with the information storage and computing proficiency. That means from the local to the cloud, how the data being communicated, right? What using it? What else are devices we are using it for? Things, the sensors and actuators, and the corresponding features. What else we have discussed, right? Gateways and network infrastructure. The IoT devices that comes under network infrastructure or routers, aggregators, gateway, repeaters. That's coming to the infrastructure. Cloud infrastructure, the concerned IoT devices are visualized servers, data storage units, right? Altogether. As of now, we have seen four components, right? We have seen four components. That is, first one is things, second one is gateways, the third one is network infrastructure, the fourth one is cloud infrastructure. Altogether, if you are integrating into three main components, that is, things are connected with network sensors and actuators. In short, we call it as TNSA. In short, we call it as TNSA. That is, things with networked sensor and actuators. The raw information and processed data source. That is RIPDS. The second component. That is the information what else can connect or generated or perceived from the things it has to be processed and stored. That was what presented as RIPDS. The last one is analytics and computing engine, where the more insight about the data is being generated for corresponding actions or corresponding for further processing. Right? The corresponding features, what else we have represented, again it is being summarized here. Things and network sensors and actuators, TNSA, that is collects the information from the objects or things, either objects or things, both remain same or represent same, that were concentrated as per the specific applications areas. It is specialized with respect to the concern areas, or it is very specific to the areas. For example, if you are concentrating with respect to agriculture, then the data has to be collected from the field. If you are applying it for the war field, or if I'm applying it for a particular temperature sensor to sense that how far the boiler sensing or boiler temperature is there. Whenever the boiler goes beyond certain level, we need to switch over the boiler or switch off the boiler, or we need to add few more components to it, such that the output will be varying one. So completely these things and network sensors actuators is not only here, but the collected data analytics all depends on a customized data or where it is being deployed. Raw information and processed stores or ideas. Source the information in various forms, such as either it might be data or text or videos, images, or even the models. Coming to the analytical and the computing engines. Coming to the analytical and computing engines. That is, it helps in the human machine interactions and allows the feedback as per the human requirements. Here mainly what we are doing is we are doing analytics, analysis, or computing. We are doing it based on the computing, and based on the requirements, we'll be going with such sort of decisions, right? And that too based on our requirement. What else we need to do? For example, we are going on for the past 6 months. I'm using IoT for my agricultural field. So based on that, I'm having some data, existing data. Based on this existing data, what I can do for improvising the overall cultivation, overall productivity, right? Or just this might be one example. The second example is just we are going using watering or fertilizers to the agriculture using drones. For example, the second application. So how the drones might be programmed, or how the instructions can be done to the drone, stating that this is the environment, or this is the area of particular crop. This fertilizer we should not use, or this fertilizer should not go beyond this level. It can be segregated, right? Coming to the features of components. What else? The way these are being interacting. See this diagram. The explanation of the diagram is given. That is, interaction between the IoT components starts from things with network. It is a cyclic nature. It is a cyclic. And whether it is audible? Madam called. Shall we proceed, or whether the screen audibility is correct? Yes, sir. Yes. Thank you. Yes. Coming to this TNSA, that is things with network sensors and actuators. This where the environment, or this is the block where the generation of data is there. That is things with network sensors and actuators. All the things are connected through the network along with the sensors and with the actuators, so that the collected data is being communicated. Right? Where it has to be done, that is raw information. Once the data is being generated from the sensor and the corresponding links, it has to be communicated to the nearby networks, right? That's for the raw information and processed data storage. The exact data is being communicated to the nearby local networks or to the concerned location, such that the data is being stored and processed, or processed and stored. Either the way we can do it. That is internal, external report states here. From here, from this raw information and processed data, what we are going to do with the original data or the same data is that we are going to pre-process the data, apply some analytics. After that, post-processing, what's the way in which I can go for make the collected data to make the overall product an efficient one. That's what we call ACE, analytical and computing engine. After the analytics, we'll be having much more insight about the data. There is awareness about the data, what the data reflect, or what way we need to interact, or what way we need to improvise. So feedback in the form of commands being given to the concerned sensor such that it forms a cycle again and again. The stored data is being, where with respect to the analytical and computing engine, the stored data is being transferred or accessed for computing or for analytics purpose. The same explanation was represented there in the previous slide, right? The IoT architecture layers, as already we said in the previous slides, IoT architecture layers. Before here, we saw about the three-layer architecture we saw, right? Yes, I'm going back. See the structure of the three-layer architecture. What else? Maybe the environment where we are applying the IoT, it comprises of minimum of three-layered architecture. It is being device or categorized. First and foremost thing is perception. Second one is network. The third one, the perception will collect the data. Network or sharing the data either to the local or to the distant or even to the cloud. Whereas with respect to application, where the corresponding IoT is being deployed, based on the collected data and transmitted data will be deployed into the concerned environment. Right? This is the structure of three-layer architecture. Whereas coming to the point here, the architecture would vary based on the requirements and based on the environment. The approach of attaining a solution is based on how the information technology components are integrated with communicating devices. Right. In brief, the software-defined hardware helps in processing the raw information to the processed data. That is, the what getting it from the sensors is a raw data. It has to be processed. From where the storing, retrieving, and analysis of data is being done using the advanced computing tools that are integrated with IoT systems. That so any restrictions that these three layers should be as such. Even we can go for these three layers would vary depending upon the requirements and the environments. Right? Sample few will see some applications, IoT applications in energy domains. Energy domain means the energy sector. What else are we going to see here? Local energy generation, home applications, remote control, whereas the light, high voltage air conditioners, security and safety, smart metering, and energy storage. These are the various applications of IoT with respect to energy domain, that is with respect to electrical and electronics engineering. Whereas coming to the security systems, biometrics, see the enrollment, whereas after enrollment, the feature extraction is done. After the feature extraction, the data is being stored. This is for, we call it as a training. Training phase will be going for testing phase. While that's what the training phase we call it as enrollment, whereas in the testing phase we call it as verification, one-to-one. So what we'll do is just we'll whenever we are providing our data set or whenever we are just providing our thumb impression or the finger impression, then it will be captured and it is being compared with the here with respect to this. Coming to the result means one-to-one, whereas initially what it has to do is 1 to n. What else the data is being stored in the database that has to match with the, all the features. Just a minute, please. Here the applications of IoT with respect to biometric systems, whereas applications of security systems are door locking, the same feature. What is the example we saw it here? This biometric system authenticates that the concerned user is X or not. The concerned user, for example, the user A is trying to enroll, means accordingly whether the same person A is available or not, or authenticated or not, we'll be checking. With respect to that authentication, we can deploy for door locking or unlocking, the same steps. First and foremost, yes, we need to enroll. After the enrollment, we will be checking whether the concerned person is there or not. If the stored person's details are matching with the person who is ringing the bell or else who is standing in front of the gate, then it opens. For example, check if the image of the person is present in the database or not. That is step one. Step two means get the response correspondingly. These are the members already enrolled, means it will open up that. User can authorize and add the image in the database. Likewise, we can add users so that we can avoid unauthorized access for door opening and closing, else notify the owner stating that whether to open or not. If the person who else is being present before the door is not authenticated user, it informs the owner stating that whether to, this is an unauthorized person, whether to allow or not. If the image is present in the database, then directly the door is unlocked. Coming to the applications of IoT smart home, you can see the environments in the home where it is being deployed. First and from left of the image, that is smart door lock. What else we have seen? Smart security systems, then smart air conditioner, then smart lighting control. That means whenever you are entering, then only the light are switched on and off based on the requirements or based on the environments. Then smart energy meter, then smart appliance control, the smart thermometer. That means whenever the temperature goes, either it applies for heater and also as well as for AC. Whenever the temperature goes beyond certain level, either it is a hot or a cool, the concerned device has to be switched on and off. Smart bathrooms, smart garage doors. Whenever we are switching on the car or the vehicle and it comes near to the concerned door, means automatically the opening and closing of doors happens. That is the smart garage doors. And the smart agriculture, we saw many examples we are going on seeing. Water management, soil monitoring sensors, the machines for routine operations, drones for field monitoring. This is a very great demand and great promising environment where the IoT along with the drones are being monitored or used monitored for agricultural purpose. Then IoT in smart healthcare, that is the sensors, once the data is being collected through the connectivity, so that it is being office or concern medical dispensaries where the descriptive, diagnostic, and event based actions are taken in the dispensary. Accordingly, it is being instructed or shared to the doctor, such that the doctor is giving an instruction through the mobile apps. So that now, due to COVID, even the doctors are, you might be have seen or you might have heard about it. Nowhere else. Just I'm not commenting. General thing, what is being happened and happening earlier and all. Over phone and all, it is not at all possible for us to discuss over to the doctor, such that it is, we might not be expressing it clearly. That's what they will use to come to the hospitals or dispensaries in person and we'll be explaining. Whereas coming to the coming to the reality, applications in smart healthcare. Applications in smart healthcare means based on the sensor which is collected from the user, then it is being shared to the physician, that is the doctor, and based on the data, will be medicated accordingly. Then the applications of IoT in smart transport either by all means, not only with respect to the roadways or landways, even seaways. Here, this diagram you can able to see the satellite communication, airways, the waterways, the landways. Land means either the road and also as well as rail, or are communicated or all are connected and communicated through the concerned devices. Right? IoT protocols, levels, and deployment templates. Prior to this, here the forthcoming slides we are going to see about. As of now, we saw the IoT building blocks, right? Then the forthcoming slides we are going to discuss about the protocols and where it is being deployed. For this, I want to switch to the other slide from the book. This completely. This is from the book. And you can able to get this book slides and also the software of the books from the internet. That's why I'm using it as such. Few slides alone not autocorrect or it might be repeated. So in those scenarios, we'll be skipping it, and mostly it deals with the protocols where we'll be concentrating on. Right? Yes. Whether the screen is visible, ma'am? Now just I switched over from that slide to another slide. Whether the screen is visible? Yes, fine. Thank you. Thank you. Thank you. Any doubts here? Clarify it for a few minutes, or else we'll be discussing at the last chapter. No problem. Shall I continue, or discuss, or wait for any clarifications, or at last we'll have it? Yes, fine. Thank you. Yes, we'll proceed. Yes, the out of this presentation, outline of presentation, definition is there, characteristics. Definition already we saw it. Again, we'll have a characteristics of IoT just in a brief, then physical design, then logical design, IoT protocols, IoT levels and deployment templates, right? IoT. Definitions already we saw it, right? That is the scope of IT is not just limited to connecting the things alone through the
Device
internet.
sending yes, device
Whether I want to stop?
sending analysis data back to call or data center. Sending
Hello.
Vimala ma'am, Vimala
good
ma'am,
morning. Good morning, ma'am.
ma'am, do you want to ask any doubt to Ramkumar sir? Or
No doubt, ma'am. All
okay,
clear.
okay, ma'am. Can you
Thank you.
unmute yourself?
Okay,
Oh,
done.
thank you, ma'am.
Okay, madam. Thank you. Shall I proceed now?
Yes, sir.
Yes, yes. That's fine, madam. Yes, the scope of the IoT is not just limited to a particular connecting the things to the internet, but it allows these things to communicate and exchange data, process them, as well as control them while executing the applications, right? Then the formal definition of IoT. This is how being represented in the book. That is, it is a dynamic global network infrastructure with self-configuring capability. This is the most uh, coined term, that is self-configuring capability based on the standard and interoperable communication protocols. The second predominant word, that is interoperable communication protocols, where the physical and virtual things have identities. Identities means particular IP addresses, or through a unique number we can able to retrieve the data from the concerned things or the objects, physical attributes, and use intelligent interfaces and are seamlessly integrated into information network that communicate data with users and environment. That means user and environment has to communicate. That's it. For communicating, if whenever, for example, a sensor is being deployed at very chill climate, that where it goes beyond 0 degrees. So in those scenarios, the resistor or else the data, the sensor has to withstand and it has to collect the data. This self in those scenarios, or else either it goes less than 0 degrees or it goes beyond 40 degrees. In those scenarios, it has to withstand configuring capabilities and the information protocol. It has to transfer the data from the place where it is being generated or where it's being deployed. From that, it is collected and communicated to the nearby networks. From there, it has to be communicated to the cloud for storing, getting in it, right? If I want to represent in a very simple manner, that's communicating the data between the user and the environment, right? Whereas most all scenarios, it is a global network. It's not restricted or not specific to a local area. In those scenarios, it works, right? So characteristics of IoT, that is, it is a very dynamic and global network. It is a self-configuring, interoperable communication protocol. It has a unique identity, such as unique IP address. Every machine in the network has the unique IP address, right? Likewise, every sensor or the every thing or the every object has a specific ID or specialized ID, so that through that ID it can be accessed by everyone else or the with privileges, access privileges, right? And integrated into information networks, right? Physical design of IoT, that is things in IoT and IoT protocols. What that word things refers, that is refers to the IoT devices which have unique identities that can perform either sensing or activating or monitoring capabilities. This is with respect to things. Whereas coming to the IoT devices, how it does, or where the collected data is, from where it collects data, the place where it is being deployed, right? IoT device can exchange data with other connected devices or collect data from other devices and process the data either locally or send the data to the centralized servers. It is not necessary that all the sensors should generate the data or should even it should be deployed. It's not necessary like that. Even there are some sensors which is used to pass the message or share the data to the nearby networks. That is also connected devices, right? Either it might be local or it might be the global, right? And it has to be, at last it has to be stored, the data has to be stored, and we need to explore it for further processing. The general or generic or the general block diagram of an IoT device, it comprises of 7 components. The first and foremost thing is, here an IoT devices consist of several interfaces for connections to other devices, such as, among that it is categorized or IO interfaces for sensors, that is input and output. The second one is interfaces for internet connectivity. So after getting the data or after providing the data, it has to share through the other devices or other networks through the internet. The third one is memory and storage interfaces. So for storing the data and for at least for maintaining the data to some extent, either it might be RAM or ROM, it has to store the data. For that, memory is required for memory and storage interfaces, audio and video interfaces based on the requirements. Not all the IoT devices are in need of audio and video interfaces. Whereas first 3 are mandatory, that is input and output interfaces for internet connectivity and memory and storage interfaces. Coming to the part here, see connectivity, through connectivity, where we will be getting connectivity through USB phone or to the Ethernet. Processor for CPU, right? Then audio video interfaces through HDMI or audio or RCA videos. Whereas IO, input and output, either these are the ways in which you can able to get the data input or the data output for subscription, that is UART, SPI, I2C, and SCAN. Whereas coming to the storage interfaces, either it might be the SD or MMC or SDIO. Whereas coming to the graphics, GPU. Whereas coming to the memory interfaces, either based on the requirements, we can go with the DDR1, 2, 3, or even for either, just for either, that's what I said, it might be the RAM or ROM. It can store, temporarily being stored, or it can be accessed, right? So 3 are mandatory, that is input, output, then interfaces and memory. Based on the last one is audio and video interfaces. Based on the requirements, we can use it. See, coming to the IoT protocols, these are the 4 layers of protocols, IoT protocols, which plays a major role in establishing the interoperability. Between the networks. That is first and foremost things, link layer. Second one is network layer or internet layer. The third one is transport layer. The fourth one is application layer. The left and right represents the same, but the order varies. Here, the first and foremost thing is link layer. In this link layer, there are 5 different categories in which the data can be communicated from link layer to the higher level layers. Link layer means those are with either through the internet or WiMAX or Wi-Fi or low rate wide personal area networks, or even with a cellular 2G, 3G, and 4G. This LTE represents a long-term evolution. Represents even other name for LTE is 4G. Currently, what else we are using it right now, right? Cellular networks. All these are the various ways in which the link layers are being communicated. Coming to the next subsequent level, that is network layer. That is either using IPv4 or V6, and the extension of IPv6 is low power. Since the same terminology uses, that's what it represents, 6 low power personal area networks. Coming to the transport layer, TCP and UDP, transmission protocol and user datagram protocol. Whereas coming to the application, there are 7 categories: STTP, CoAP, WebSocket, MQTT. MQTT stands for message queue, telemetry transport, XAMPP, XMPP, DDS, and AMQP. We will be seeing in the forthcoming slides. These are different IoT protocols. These are the different IoT protocols, that is link layer, network layer, transport layer, and application layers, right? With respect to the link layer, see, as already stated, there are 5 categories. One is Ethernet, Wi-Fi, WiMAX, LR, WPAN, and 2G, 3G, and 4G. Now we will be seeing the link layers, what is the way in which, and its characteristic features, how it is being communicated or how it connects the data. Right? The first one is link layer. In that, Ethernet, right? The standards of Ethernet are 802.3. Then it uses coaxial cable, directly disconnected through the cable with the special with the capacity of 10 base 5. Whereas 802.3.I, that is, it uses copper twisted pair 10 base T. Then 802.3.J, it uses fiber optics such that the speed increases somehow when compared to the normal coaxial cable. Copper wire has much more speed or the capacity with less delay or less latency. when compared to the copper wire, again the fiber optics has much more faster, but with respect to the cost, it is much more costlier when compared to the coaxial cable. And last, the fiber optics, you can see the speeds, the ranges, the data rates are provided from 10 gigabits to 40 gigabytes GB. With respect to fiber, see here, it goes directly to the 10 gigabytes. The standards are 802.3.AE. This all with Ethernet, the wired cables, right? Coaxial cable, either it might be the coaxial or copper twisted or fiber optics, all are connected through cables only. That is shared medium. Coming to the next layer, that is link layer with Wi-Fi. Then that is, these are connected through Wi-Fi. Much more speed increases without the direct connectivity, that is wireless connectivity. That is 802.11a standards. The maximum it operates in 5 gigahertz band, whereas 802.11b and 11g it operates 2.4 gigabytes. Whereas the subsequent standards 802.11n AC and AD it operates in 2.4 to 5 gigahertz, whereas 5 gigahertz and 60 hertz. Whereas what is the maximum speed, or what is the difference between the earlier connected wired and wireless means? It is a collection of wireless LAN, whereas the data ranges from 1 megabits to 6.75 Gbps, right? Much more speed increases, right? Then Y max, again it goes beyond somehow for wider networks or bigger the networks with much more capacities or counts numbers, right? Its standards is 802.16 m. Then 100 Mbps for mobile stations and 1 Gbps for fixed stations. That means if you are working with the mobile station, then the speed is restricted to 100 Mbps. Whereas if you are going for fixed stations, so that from the fixed stations we can able to go for bifurcating or dividing into much more individual stations. So the capacity for fixed stations are increased. That is, the data ranges from 1.5 Mbps to 1 Gbps. This is link layers Y max. Coming to the LRWPAN, that is collection of standards for low rate wireless personal area networks. As the name indicates, wireless personal area networks, basis for high level communication protocols such as Zigbee. This forms the basis. From here only the evaluation lead to Zigbee protocols, where much more higher speeds of networks are available. Whereas with respect to LRWPAN, that is, as the name indicates, as already we stated, LR, low rate wireless personal area networks. So the data rates are very less, and where the power constraint is more, or the power constraint has to be concentrated more, then we'll be going with this sort of protocols. That is, provides low cost and low speed communication for power constrained devices. Coming to the next layer, link layer, that is 2G, 3G, and 4G. 4G, what we call it as LTE, long term evolution. So if you are seeing now, 2G means GSM, CDMA, 3G, UMTS, that means Universal Mobile Telecommunication Systems. Universal Mobile Telecommunication Systems and CDMA 2000. This lies in the category of 3G. Whereas coming to the 4G, LTE, whereas now we can able to see, right, even Geo, and even thanks to the telecommunication advancement, stating that even with the mobile phone itself, you can convert or you can make it as a hotspot, and even you can share to the nearby friend. But it is not advisable, and even though much more members are going on repeatedly representing that you don't go for mobile hotspot sharing to the unknown or unauthorized persons, so that they can even hack the apps or hack the mobiles. It is not advisable, but for technology point of view, I am just saying and sharing this point, right? Just even that sort of much more facilities we are getting it with the help of 4G, such that the data rate ranges from 9.6 kbps. You can able to see the speed. 9.6 kbps means this is for 2G speeds, whereas coming to the 4G, then it comes up to 100 mbps speed in the even the normal mobile phone itself. That much speed we have now. One statement also said for this. Now what else, the initial satellites, when the time even in the 1800s or even the 19 the initial levels, where we are sending the missiles, in those scenarios that much capacity only was there, whereas currently those missiles capacity is much more less than when compared to the mobile phones. What else we are having it in our hand right now. The normal mobile phones are having much more computing speeds with hexa process or octal process, which consists of 8 process for doing much more parallel processing, and to with higher RAMs, minimum of 8 GB to even 6 GB, 3 GB, 8 GB, and even higher ends, right? Coming to the, just I'll go back. See here, this link layers. Right now we saw the Ethernet, Wi-Fi, WiMAX, low rate wireless personal area networks, and 2G, 3G, and 4G networks. We saw it. All these communications with respect to link layers. Coming to the network and the internet layers, the next level we are moving up, one level up higher. Network layers, internet layer, that is responsible for sending of internet protocol datagrams from source to destination networks, right? Performs the host addressing and packet routing, and host identification is done using hierarchical IP addressing schemes such as IPv4 or IPv6. Earlier we were using IPv4 due to the much more congested networks being moved to IPv6 for higher number of systems being connected to the networks. IPv4, that it uses 32-bit addressing scheme, whereas IPv6 it uses 128-bit addressing scheme. Coming to the even much more higher, if you are going for higher grades or higher data rates, then goes with the updated version of IPv6, that is 6 LOWPAN, that is low power wireless personal area networks, which is mainly used for the devices with less power or power constraints. The devices which, for example, are mobile. You just think about it, if you are charging it, then it goes with maximum of 24 to 36 hours, right? Where the morning to evening, okay, after that evening everyone's battery will be drained off, or where the power consumption is very much more criteria. Whereas coming to the PCs or general systems where there is no need of training about the power, we can go for other protocols. Whereas this particularly these protocol or these protocols are being used for the limited processing capacity the concerned devices, then operates in 2.4 gigahertz. Data rates ranges from 15 kbps, right? Coming to the transport layer, that is, as the name indicates, transport layer, it provides end-to-end message transfer capability such that it has control, segmentation, flow control, and congestion control also. There comes into the picture the TCP and UDP. The TCP and UDP. TCP stands for Transmission Control Protocol. The same networks, what are the networks and communications we have gone or came across many number of times, right? Transmission Control Protocol. This is a connection-oriented one. Always this TCP ensures the reliable transmission, and it ensures the congestion-free traffic, because always it goes with the handshake mechanism, that is provides a detection of capability to ensure no duplicates of data packets are being transmitted. That is, flow control is ensured to ensure flow control capability to ensure that sending data rate is not too high or not too low. That is, optimal level of speed will be there such that the sender and receiver are synced to each other, such that the data transmitted will be reaching or will be reached to the sender, to the receiver on time or correctly. Right. Congestion control capability helps in avoiding congestion, which leads to degradation of network performance. This is with respect to TCP. That is, in short, we call it as handshake mechanism, right? Such that whenever the sender is requesting or to the client, or the client is requesting to the server, according on that the data is being communicated with any congestion or no duplicacy. Right? Whereas with respect to the other protocol, the extreme, the other case protocol called as UDP, user datagram protocol, it is not connected, right? There is no any link between the sender and the receiver, such that the sender will be going on sending the data. It is the responsibility of the receiver to rearrange it, and whether even there is no any criteria such that whether the same data is being communicated over the network or not from the sender. So the receiver, upon receiving, he has to organize, reorganize, and collectively together, whether the arranging the data, it becomes much more overhead. That's what's here. Does not ensure reliable transmission, does not connect, does not do connection before transmitting, does not provide proper ordering of message, transaction oriented and stateless. Right? These are the features of UDP. Coming to the application layer, coming to the last layer. Again, I'll go to the first slide so that we can that won't be getting confused. See here, as of now, the link layer, this 5 we have discussed, and network layer IPv4, V6, and 6 low power wireless personal area networks. We saw it with respect to transport, TCP and UDP. We have seen. Coming to the application layer, this 7 points or 7 types of categories we need to discuss. We are right now here. We need to discuss here, right? The link layer, network and internet layer, and transport layer we have completed. We are now moving to the application layer. application layer. In this application layer, out of 7 categories, the first one is hypertext transfer protocol, STTP, hypertext transfer protocol, right? Here, it is the foundations for www, and it has the commands such as get, put, post, head, options, trace, etc., and follows a request to response model. It follows a request and response. Based on the request, the response will be there. Based on the request, the response will be there. Uses URI, that is universal resource identifier, or in the URL. In the URL means uniform resource locator. In the uniform resource locator, we will be specifying a particular file ID, so that in the file ID, by specifying that file ID, we can able to retrieve the files. We can able to retrieve the files to identify the specific data or the specific location in the www. URIs, that is universal resource identifiers, are being used. This is with respect to hyper transfer protocol. Coming to the application layer COAP, that is constrained application protocol. That is constrained application protocol. It is mainly used for machine-to-machine applications, meant for constrained devices and networks. Right? Web transfer protocol for IoT uses request. This also uses request response models. That is request, based on the request only, the response will be generated. Right? Uses client server architecture. Wherever the client server architecture is there, mostly it goes with the request response model. Right? Supports methods such as get, post, put, and delete. That is where the data is being shared between the client and the server. These are some of the methods. Right? Coming to the third layer of web socket, that is allows full duplex communication over a single socket. So full duplex means both the client and the server can interact each other at the same time. That is full duplex communication over a single socket. That is based on a TCP, and client can be a browser, IoT device, or a mobile applications. The various forms or the various categories of clients may be of browser or IoT device or even the mobile application. Coming to the application layers of the next application layer, that is MQTT. MQTT stands for Message Queue Telemetry Transport. Message Queue Telemetry Transport. MQTT. It is a lightweight messaging protocol exclusively designed for IoT. That is, I repeat, it is a lightweight messaging protocol. That's to be a message queue telemetry protocol that is purely based on a publish subscribe model. It is based, whereas prior to that, these some applications, what else we have seen, that is based on a client request response. See here we saw it in a request response, or earlier request response model. This hyper transfer protocol is a request response model, and here the client server architecture, here this COAP, constrained application protocol, is also a request response model. Whereas coming to the WebSocket, again it is a TCP, so the handshake comes into the picture. Whenever the handshake model comes into the picture, that request response will be there. Whereas coming to MQTT, that is message queue telemetry transport, here it works on the model of, or on the basis of, publish subscribe model. One very best example I want to represent here is publish and subscribe model. In YouTube, we are having any number of channels, not only videos, I'm talking about the YouTube channels, or else coming to the, I'm not that much aware of it. Let me go with the example, and I'll come to the second example later part. There are a number of channels are available in YouTube. If you are particular, much more interested in a specific channel, you just subscribe it. Then whenever you are subscribing a particular channel, you will be notified when there is an advancement or when there is a new post in this particular channel, right? This is example number one with respect to publish subscribe model. The same thing, if I'm applying that example to our DTH, what else we are using, not to the channel. If you are going with any of the DTH, any DTH channels, there will be a minimum of hundreds or even hundreds and hundreds of channels are there. That is published already. From their end, they are going on publishing. Free channels you will be getting by default, no problem at all. If you are paying a minimum cost, either 150 or 170 or 200, for example, 200 rupees if you are paying per month, means you will be getting, or you will be come up with a very basic package. Apart from that, if you want to go for a specialized any channel, then you need to subscribe for it. Based on the subscription of the channel, you need to pay for it, and pay and use likewise. So based on the publish subscribe model, this MQTT works. It is a very lightweight message protocol exclusively used for communicating between the IoT devices, right? Well suited for constrained environments where devices have limited processing, low memory, and network bandwidth requirements. Even with very low processing capacity, low memory, and lower network bandwidth, this MQTT supports, or it works, right? Coming to the next layer, next protocol that resides in application layer, that is XMPP, that is Extensible Messaging and Presence Protocol. I repeat, XMPP, that is Extensible Messaging and Presence Protocol. That is, it is mainly used for real-time communicating and streaming XML data between the network. Where here I want to represent one point with respect to XML, where you might be knowing it with respect to the Android machines or Android applications. With respect to Android applications where the database cannot be stored, then we can go for SQLite. SQLite. That means there is no need for installing the database directly. You can copy paste the folder and you can use it as a database. Right? Where even there are some locations or environment where that sort of SQL cannot be even represented. Those are with very less memory. Then you can go with a substitute for it as XML, which acts as a database, which can be represented as a database. It is not a substitute for a database in those scenarios where the power consumption is very less or the memory consumption is very constant or limited. Then you can go for just XML features. That is for real-time communication and streaming XML data between network entities. Used for applications such as multi-party chat and voice and video calls, whereas the decentralized protocol and uses client-server architecture. Right. Then into the next protocol, that is DDS, Distributed Data Distribution Services, is a data-centric middleware stands for device to device or machine to machine communication. That is, here also the publish subscribe model is being implemented, and it provides or it has much more impact on quality of service. Right. Then the next protocol is AMQP, Advanced Messaging Queuing Protocol, is used for business messaging and supports both point-to-point and publish subscriber model. Here, point-to-point means one-to-one. The who else is having least line, they will be given with much more priority with the higher data rates. Right? That example we can have, that is point-to-point. Whereas publisher subscriber model, the same. They will be going on publishing. Who else is interested, they can subscribe. Right? Routing and queuing. Broker here receives messages from publishers and route them over a connection to the consumers through message queues. We'll see the examples for this. Logical design of an IoT. Logical design of an IoT. Here, this is the very basic model you need to concentrate on, so that the subsequent slides depend on this design only. That is, logical design of an IoT refers to an abstract representation. That means by default, all the devices should comply or they should have this sort of designs. That is, of entities and processes without going to the lower level specifications. For example, an IoT system comprises of a number of functional blocks that provide the system the capabilities for, first and foremost thing is identification. The device has to be identified. The second one is it has to be sensed. After the sensing, it has to activate, and based on activation, it has to communicate and management. For all those things here, the device communicate services, it has to be managed with security. At last, the data has to be shared to the application. Just I repeat, with respect to this diagram, that is, first and foremost thing is device. It has to communicate with the services. These communication and services are to be managed with security, and after that, the collected data from the device has to be shared to the application. Right? The device means device sensing, activating, monitoring, communication through IoT protocols. What else we have seen right now? Then services like device monitoring. See the same. Here we said now the services. What the services meant? Like device monitoring, device control services, data publishing, and device discovery. Or management. What is the management? Functions to govern the system. Then security. What is the way the security meant here, or security is required? Functions as authentication, authorization, message and content integrity, and data security. At last, the applications. Right. See, the client. This is the very basic model. Communication model is request and response model. Based on the client request, the server responds, and the resources are also being provided access to the client. Right. So here, the request response is a communication model in which the client sends a request to the server, and the server responds as the very normal client server technology only here. Right. When the server receives the request, see here, the client sends request to the server. Right. Receives request from client, process request, looks up, fetches the resources. If the concerned resources is available, then those resources are made available from the server end to the client side. prepares the responses and sends response to the client. Based on the client request only, the server will be responding. What else the responses the server can provide the client, that is fetching the data, how to respond, or retrieves the resources, prepares the data, and then sends the response to the clients. It is a stateless communication model. That means every time you need to link up, or you need to ensure that you are the correct person you are accessing it. For this very best example, I'll tell you. If you are in your mobile, your Gmail account will be always on. No problem at all. Whenever you are clicking mail, directly it goes opens and open up, and you can see your mails. Whereas in your personal system, either the desktop or the laptop, whether you are using it in the college or else in the home, just you are typing gmail.com, you are logged in. Without signing out, you are just closing the uh, browser itself. You are opening the browser by afternoon, or else on the next day, or else even the next week. Whether you might be seeing that if you are not logged out and directly close the browser means, whenever you are typing gmail.com, directly it enters to your inbox, right? This is what it ensures. There is no any necessity there. It will be prompting you to enter your password, unless otherwise you are clicking that sign out of all options or sign out of all accounts, right? In those scenarios, see here, the same example will be applicable to the subsequent slide. I'll tell you. I'll come back to the same example again. Right? This is publish subscribe communication model. That means it is a communication model which involves, see here, publisher and broker and consumers are there. Publish and subscribe. Publisher is always, his responsibility is to publish, go on. For example, we are going on DTH. In the DTH, they will be going on providing all sort of channels. It is your responsibility to choose the channels. Based on the channel you have chosen, you need to pay for it. The same case. In the broker here, what will do? Message is published to topic 1. For example, topic 1 subscribers. Here the broker is responsible. He is responsible for getting or maintaining the concerned consumers who else is been connected with the concerned topics. So here with respect to this example, consumer 1 and 2 are linked up with the topic 1, whereas consumer 3 is linked up with the topic 2. Consumer 3 alone is linked up with topic 2, so it is being shared because consumer 3 subscribed to topic 2. That's it. If he wants to go for adding, or he wants to be communicated or with the subscribe with the channel 1, means accordingly either to the topic 1 means again based on the requirement or based on the interest only, right? The consumer subscribe to the topic which are managed by the brokers, right? Here coming to the next model called as push-pull communication model. Push-pull communication model. Here there is a separate queue is maintained for exclusively to the individual consumers based on the content requirement. All the data will be kept in a queue, and based on the items in the queue, the consumers are being processed. Right? That's what the name as push-pull communication. The publisher pushes the data, whereas the consumer pulls the data. That's what push and pull communication model. There's a communication model in which the data producers push the data to the queue. That is, producer, once the data is being prepared or ready, they will push the data to the queues. That is, the consumer pulls the data from the queues. The producers do not need to be aware of consumers. There is no any necessity such that this many number of consumers are consuming. Publisher generates the data and pushes the data to the queue. That's it. Whereas from the queue, it is the responsibility of the consumer to get the data. Right. Queue helps in decoupling the messages between the producer and the consumer. When the data increases, accordingly the queue increases. When the data is reduced, the queue shrinks. Right. Then the queue also acts as a buffer, which helps in situation when there is a mismatch between the rate at which the producer pushes the data and the rate at which the consumer pulls the data. That's it. Whenever the more the data is required by the consumer, then accordingly the queue data has to be expanded, and whenever the consumption by the consumer is less, then accordingly the queue shrinks. That too mainly depends upon the scenario and where the data or how the data is being processed. Exclusively pair communication model. Exclusive pair. It is a client server model that exclusive. That is the one example will be representing a handshake model. Whenever there is a request from the client, the server responds. See here, the request to set up connection. Client requests the server for setting up a connection. When the server is ready, it accepts. Then all the data between the client and the server is being shared. See here, message from the client to server and the message from server to the client. All the data, either it might be 1 bit or 1 byte or 1 KB or even 1 MB or 1 GB, no problem at all. Whatever the data is being connected, Whenever the connection is being established between the client and the server, all the data communication is being done. Once the communication is being done or completed, then the connection close request by the client, either it might be the connection close by the request is either might be the server is the client might be pulled up or requested by the other server, or the communication might have closed for the current day or current session. That all depends upon the scenario. Again, once the client connection request done, the server closes it, right? The same, the REST-based communication APIs. REST-based means representational state transfer. There are two categories. One is REST, the other one is APIs. Here we'll see the REST-based. One more is WebSocket. These are the two very basic communication protocols used by the IoT. REST stands for representational state transfer. Representational state, so that is, it is a set of architecture principle by which you can design web services and web APIs that focuses on systems resources and how resource states are being addressed. That is, this REST also follows the request response communication. REST also follows request response communication. You can see in the diagram, right side diagram, HTTP client, then HTTP packets are being done. Once the HTTP packets are done, it request to the HTTP server. And what the HTTP server does means, here, based on the resources, whether the concerned resources is available or not. If it is available, directly it allocates to the concerned client based on its request. If not, it has to wait again. Right. The REST architecture constraints apply to the components, connectors, and data elements within a distributed hypermedia systems. Again, as we said, it follows the request response communication. As it follows the request response communication. See here, when the client request, based on the client request, the server responds. Based on the client request, again the server responds, right? Client server, it is a stateless, it is a cachable layered system, uniform interface, and the code on demand. That is REST based. Representational state transfer. Coming to the next communication type, that is API, is that is WebSocket based. WebSocket based. It allows a bidirectional full duplex. Wherever the full duplex word comes into the picture, on same time you can have client and server communications will be done. Just a minute, please. I'll be back in a couple of minutes. Sorry. Extremely sorry for the inconvenience. Unless I want to attend the, I was forced to attend the call. Sorry. Whether it is audible, ma'am? And the screen is visible? Yes. Thank you. Thank you. Thank you. It is a WebSocket based communication API. It is completely bidirectional full duplex communication between the client and the server. It allows exclusive pair communication model. Exclusive pair means the client and the client is connected with the server exclusively for that period. The server also wants to communicate to the client on exclusively during the period, so that there won't be any disruption in the during the communication period. Right. The request to set up WebSocket connection, the response accepting the request. That is, first and foremost thing is initial handshake. Client is requesting the server such that I need to share the data. So whether based on your availability, we need to transfer. So the client and server is being connected. Once the client request is being accepted by the server, then bidirectional communication takes place. That is, over persistent WebSocket connection. That is, the data frames are being transmitted or shared between the client and the server. Once done, whether it might be for 1 second or 1 minute or 1 hour or 1 week or a day, based on the scenario I am saying, based on the example or based on the requirement, it will be done. Most probably it won't go for that many number of data, but mostly in the it might be in the minutes or even it might be in the hours, not together for a day also. Right. Once all the transmission is being done, the closing of connection is being carried out, the two from the client's request and the server response. Right. The difference between the REST and the WebSocket based systems with respect to 6 criteria, that is state. Coming to the state, that is REST and WebSocket. The REST is a stateless and the WebSocket is a stateful. That means why it is stateful means fully it is being connected and those dedicated timing is being shared by the client and the server, such that those are authorized and authenticated transactions are being taking place directional, whereas REST is unidirectional and WebSocket is bidirectional. Whereas a request response and the full duplex means flow request response model. That means based on the request only the response is being shared with respect to REST. Whereas exclusive pair model means during the transmission both the client and the server, you can see here during the bidirectional communications here, that's what is being done, full duplex communications. That means during this data both the client and the server are being communicated. Exclusive pair model is being taken care there. TCP connection means each HTTP request involves setting up a new TCP connection, whereas involves a single TCP connection for all requests. Once it is connected, until the completion of data transmission, it is being connected. That's what the major advantage with respect to WebSocket. Whereas header overhead, that means what else the problems or conditions with respect to the header. Each the request carries a HTTP header, hence not suitable for real time, because every time for example 10 messages has to be shared, means all the messages will be headed with the header, whereas here for only once with respect to the WebSocket, since it is exclusive pair model, the connection alone for by the time of request alone the header and the concerned packets has to be added up. Once the connection is done, so does not involve overhead of the headers. So until the completion there is no need of adding the headers again with respect to WebSocket. Whereas scalability, both horizontal and vertical are easier, whereas only vertical is easier. As the number of connections between the client and the server going on increasing, some we can go with a WebSocket. Whereas since we got, if you are not concentrating about the header issues or the overhead with respect to headers and much more complications involved, then it has to go with REST. If you are going with a exclusive pair model, then with bidirectional with stateful capacities, then it is advisable to go with WebSockets. Right? IoT enabling technologies, where the IoT plays a major role. Yes, wireless sensor networks, cloud computing, big data analytics, and embedded systems. These are the environment where the IoT plays or has its own footprint nowadays, much more technological world. Right? IoT levels and deployment templates. What else we saw it? Right? Devices, resources, control systems, databases, web services, analysis components, and applications. These are the various levels and deployment templates. We are going to see it in the forthcoming slide. That is devices means. That is an IoT devices allow identification, remote sensing, activating, and monitoring capabilities. This is what we represent as devices. Coming to the resources means these are software components which collects the data from the device, accessing, processing, and storing sensor information or for controlling the activator connected to the device. Right? Resources also include the software components directly from the data collected from the device. It has to be monitored by the client through the softwares. Right? Controller services, that is controller services, it is a native service that runs on the device and interacts with the web services. For example, the controller service sends the data from the device to the web service and accordingly and vice versa, and receives commands from the applications for controlling the devices. See, for the devices where the data is being generated, the resources where the data has to be monitored or be collected. By controller services, how the data is being controlled in the database. Collected data has to be stored. Either it might be the local or it might be at a server or it might be at even the cloud. Right? Data can either be the local. The database might be at the local or it even might be at the cloud. Whereas coming to the web services like serves as a link between the IoT devices, applications, databases, and analysis components. Say call it as just now we saw it, right? WebSockets or HTTP or the REST. Right? Then analysis components. how we are analyzing it, so that we will be getting more insight about the data. We will be getting more awareness about the data. We will be getting much more knowledge about the data, such that we can use it for forthcoming processings or forthcoming predictions or forthcoming applications. Right. This is reasonable for analyzing the IoT data and generating results in a form that is easy for the user to understand. At last, the application where the user involvement is more, based on that the user can able to interact with the devices. Right? IoT applications provide an interface that the user can use to control and monitor various aspects of the IoT systems. Right? These are the 7 components: device, resources, controller services, database, web services, analysis components, and applications. Based on the location, based on the area where these components are being deployed, the IoT applications are being categorized. See here, this is level 1, IoT level 1. See, with respect to what else the applications we saw it here, what else the components we saw it here. Or first one is device. I repeat again. So for better understanding, I am repeating this. Just these components alone, I am repeating again. That is device, resources, controller services, databases, web service, analysis components, applications. See, if all the devices are at a local machine alone, there won't be any device or any component in the with respect to the cloud. In those scenarios, we call represent as IoT level 1 and vice versa. That is, IoT level means it has a single node or a device that performs sensing and or acting. Either it may sense or it can go with activation, or it performs both sensing and activation, stores the data, performs the analysis, and hosts the application. All functionalities are taken care only at the local level. That means device, that is monitoring node, performs analysis, stores the data. Here, the same, from the device, the data is being connected to the resource, then controller services, the data is being stored to the database. From the database, the rest of the socket services, and it is being communicated to the app. All these levels or all these components resides at the local level alone. That is, level 1 IoT systems are suitable for modeling low cost and low complexity solutions, where the data involved is not big. There is no any collection of data, much more or huge data won't be available there, and the analysis requirements are not computational intensive. The two, there is no any since because of there is no much more data, there is no much more complications in the computations. Okay? The best example is home automation. The best example for level 1 is home automation. That is automation of sensors, automation of doorbell, automation of door opening system, electric pot or air conditioning, sprinklers, and smoke detectors, light control and control panel, all those things. See here, all the results, no need of, if you want to monitor this from the remote, then there is a need for cloud storage. Unless otherwise, it is not required. Right. This is with respect to the example of level 1. Coming to the level 2, see, partially coming back to this level 1, all the components resides at the local level alone. There won't be any categorization to the cloud. Coming to the level 2, see, there is a distinction between the local and cloud. Until the data collection by the devices, resources, and controller services all are at the local levels. After, once the controller services, the data is being moved to the web servers, there the data is being stored in the cloud for distant access or distant access, or also for remote access. That's what distant and distant access, with authorized and remote access. That is, a level 2 system has single node that performs sensing and activation at a local analysis. That is, getting the data and sensing and analyzing is being done at local, whereas data is stored in the cloud and the application is usually a cloud based. Right? IoT systems are suitable for solutions where the data involved is big. With respect to level 1, the data is not much more, whereas here the huge data invention is there or intervention is there. However, the primary analysis requirement is not computational intensive and can be done locally. The primary requirement of data can be done at a local level, whereas with much more storage data, the data storing is done at the cloud. In the lower part of the diagram, you can see monitoring node and performance analysis is being done to some extent at local part, whereas the storage is done at a cloud. The best example for level 2 is smart irrigation system. Smart irrigation system. For example, I'm having for example, I'm saying 10 acres of land at location 1, 10 acres of land at location 2, another some part at location 3. All those being it's very hard for me to go the individual farms and monitor it, right? So in those scenarios, all the data can be stored into the cloud, and by sitting at location N or some other location, I can go for monitoring all the fields. What else I'm having, location 1 to location pressure, helps, and are being connected to these type of sensors are connected to through the connectivity Wi-Fi, so that since it is being connected to the cloud, I can able to share the data at different locations. Right. This is the best example for IoT level 2 with smart irrigation. Coming to the next level, that is level 3, much more huge data, much more storage, much more analytics when compared to the level 2. That is IoT level 3. IoT systems has a single node. Here also the single node, data is analyzed in the cloud, and the application is a cloud based. Right. As coming to the specialized or the distinct feature or the significant feature of level 3 is that where here the data involved is big and the analysis requirement are computationally intensive. That's how we are moving to the cloud with the storage and also as well as analytics. See, whereas here with respect to the level 2, where now I keep having my mouse there here, that is level 2. Here we will have cloud storage alone. There won't be it does not involve that much computations or analytics or analysis. Whereas coming to the level 3, cloud storage is required and also as well as analytics is much more required when compared to the level 3, right? Where, see, the best example for IoT level 3 is tracking of packages. Now you can sit in your home and you can track the package you have ordered through Amazon, or else what is the online shopping stuff there. Please don't think that I'm going on promoting Amazon. It is not like that. But for understanding, I'm using this word. Wherever, right from the payment of the item until the item is being dropped at your home, there is no each and every place where it is being, whether it is started shipping or not, or started packaging or not. Once it started shipping, from that day onwards, day 1 onwards, mostly if you are seeing that is also STM plays major role with respect to the online purchases or online uh, websites. If they are, most probably while ordering, you will be given with minimum of 7 to 8 days of delivery, but they are making our mindset to stick on to that minimum number of days to reach our home as 7 or 8 days. But prior to that itself, 1 or 2 days minimum 1 or 2 days. Rarely it goes beyond the scheduled date. Shipment, where it is either it reaches or where it reaches your hub, and where the hub it was. From there, when it will be out for delivery, and what out for delivery means morning 7 a.m. to evening 9 p.m. you will get those products, and after the delivery you will be getting notified either through mail or messages or what else the way in which are available. Right, sensors are used to transfer and gyroscope. That is where products are much more sensitive for movements, or it can be handled very safely. It should not be moved. All those things can be checked with the sensors, right? IoT level 4, it is much more complicated than level 3. It is has multiple nodes. Earlier and all, you can see you can have a monitoring node, only one will be there. Whereas coming to the level 4, you will have multiple monitoring nodes, such that for each node, the concerned device, concerned resources, concerned controllers will be there, right? Yeah, level 4, I have multiple nodes that performs local analysis. Data is stored in the cloud, and also the application is a cloud based. Since more nodes are there, more devices, hence only accordingly more resources, accordingly more controllers. Since because of more controllers, more data has to be stored and more analytics has to be done in the cloud side. And here, level 4 contains local and cloud based observer nodes, which can subscribe to and receive information connected to the cloud. Here also it forms or it goes with the subscriber model, publish and subscribe model, right? Level 4 IoT systems are suitable for solutions where multiple nodes are required and the data involved is big and the analysis requirements are computationally intensive, right? See, the sensors are used, there's many number of sensors are level 3 example, noise monitoring. To a certain level, we could not go beyond all those things, right? So in those, every sensor is responsible for generating its own data and accordingly it has to be monitored. So computation also becomes huge. Level 5. The level 5 ecosystem, see here the cloud storage, in between the routers, that means in between the local and the cloud, there is another domain or another manager called as coordinator, who is responsible for coordinating many number of nodes and also as well as cloud storage and analysis. Cloud storage and analysis. Here the coordinator you can able to see here. That is a level 5 IoT system has multiple nodes and one controller node, coordinator node. Multiple nodes to monitor or to maintain, to coordinate with the multiple nodes, a coordinator is there, right? And n nodes perform sensing and actuators, whereas the data is stored, analyzed in the cloud, as similar to that of earlier levels. All the nodes are being controlled by a coordinator. That's it. To have, since because more number of nodes are there, for providing seamless connectivity or seamless processing, a coordinator is appointed between local and cloud, such that the data is authenticatedly shared across the layers, right? Suitable for solutions based wireless sensor networks in which data involved is big and analysis requirements is computationally intensive. When moving from level 1 to level 5, the data handling is increasing such that the intensive analysis is also required, right? Level 6 IoT, level 6. Apart from that, has multiple independent nodes. You can see the difference here. You can able to see the difference here. Control, centralized controller is there. This is level 5 and this is level 6. This is the only difference between level 5 and level 6. Level 5 local and cloud is there. Here, in with respect to the local, devices resources control is there. The same devices resources controllers are there. Coming back to the 6th level, yes, centralized controller is placed explicitly between the local and the cloud, such that the authenticated seamless connectivity will be there between the client and the server, irrespective of the protocols what we are using it, right? The data is stored in the cloud and application is cloud based, right? And what is the much more advantage here is that the results are visualized to the cloud based applications. Completely the results are being moved to the cloud based applications, right? These are the various levels. Coming back to this protocols, these are the protocols and various levels we saw it. Now where it is being deployed, we'll see. These are the various levels of IoT protocol levels we saw it. Just see, these are the protocols, enabling technologies level. Level 1 example is home automation, where only the local will be there. Level 2 is slightly we are moving to the cloud from the local machine, where the example is smart irrigation. Level 3, much more computation. Along with the storage analysis, we'll be having analysis part also here. With respect to level 2, only the cloud storage is there, whereas with respect to cloud storage, moving from level 2 to level 3, we'll have analysis also, analytics. This example is tracking the packages. Level 4, much more huge computations. Level 5, in order to go with or satisfy much more individual ends or individual router points, we are trying to have a coordinator, exclusively coordinator, whereas in level 6, centralized coordinator is there, right? Now, with these protocols and the various levels, how it can be deployed, or what else the way in which it can be deployed. See here. Coming to this levels, what else the levels we saw it? What else the levels we saw it now? Based on the environment or based on the requirement, even the IoT architecture have or can be categorized into 3-layer or 5-layer or 5-layer with a distinct modified 5 layers or with a distinct applications, 6-layer, 7-layer, and even go with a 6-layered other modified 6-layer as fog layers. These are the different layers of IoT based on the requirements can go with. We will see that individually. If you are going with the 3-layer architecture, what is that? What else the layers are there? Perception, network, and application layer. Hope you remember in the beginning slide we shown to you. That is perception layer, network layer, and application layer. Could able to recollect this example, right? The very beginning, I saw, yes, see here, the IoT structure of 3-layer architecture. That is perception, network, and application, right? Perception is the layer where we are collecting the data. Network is the layer where the data collected data is being shared, and application is that where the end users reside. Perception, network, and application, right? The same slide, the same 3-layer architecture, perception, network, and application. Perception, the network, and application, the same layer, same 3 layers. Just 10 minutes for done. Perception layer, network layer, and application layer. Perception layer means the feature of this layer would be a sensing capability. collects and gathers information about the environment where the smart objects are available. Coming to the network layer, the feature of the layer is to enable the transmission and processing. Processing of collected data from the current layer, from the perception layer, the higher layer. What is the higher layer? The application layer. Its main feature is to deliver the specific service based on the application type to the user. This is with respect to 3-layer architecture. Coming to the 5-layer architecture, as already we saw that the perception layer is the layer where the sensor is being deployed and it is responsible for gathering the data. The network layer is for transmitting or transmission of the processed data or processing data. Or the application layer is where the users are there, is to deliver the specific services based on the application to the user. Just to deliver the data, process the data to the user. That's it. Coming to the next layer, wherever the higher layers you are going, either 5, 6, or 7, the responsibilities of these layers remain same. Perception layer is the layer where the data is being collected. Network layer is the layer which is responsible for processing the data to the higher layers. Application layer is the layer where the data is being processed to the client or submitted to the client based on the application, right? Sorry. Coming to the 5-layer architecture, the 5 layers are perception layer, transport layer, processing layer, application layer, and business layer. The perception layer, transport layer, processing layer, application layer, and business layer. Coming to the perception, as already stated, this layer is responsible for collecting the data from the sensing capability. Transport layer, new layers are incorporated, or one is the transport layer. It helps in transferring the information, right? Sensed by the sensors. That means, irrespective of the. Sorry, sir. Just a minute. I'm getting a call from the admin. Just a minute, please. Sorry, extremely sorry for the inconveniences.
Ramkumar sir.
Yes. Sorry, sir. Extremely sorry for the inconvenience. Sorry. So whether it is audible, sir? Shall I continue? Yes. Thank you. Thank you. Thank you for the immediate response. Thank you. Yes. Coming to the transport layer, it helps in transferring the information sensed by the sensor available or equipped in the perception layer, the earlier layer, that is through the network, such as either it might be the wireless or 3G or LAN or WAN. It communicates the collected data to these higher layers. Processing layer. This layer is responsible for the storage, information storage, analytics, and processing of data, such that the different vendors, the different requirements based on that it has to be sorted out. Coming to the application layer, its main feature is to deliver specific services based on the application to the concerned users. Coming to the business layer, it manages the entire IoT system where all applications can be managed, especially the business and profit models, in a user-friendly way with privacy. Here, the privacy plays a major role. Then, overall layer or the overall processing is monitored by this particular business layer. That's why it was said as it manages the entire IoT system in its 5-layer architecture. Even again, the other one more architecture layer of 5-layer architecture is perception layer, transport layer. Earlier, perception, transport, processing, and application was there. Na? Here, processing, application, and business layers. Here again, these layers, functionalities are being carried out here. Application layer, sensing layer, communication layer, service layer, and infrastructure layer. Right. Coming to the application layer, collects the information as said earlier. Sensing layer, it allows the interaction between the application layer and the sensing layer such that by means sensor elements and electronic devices are done correctly or connected correctly, and the eventual data or the exact data what is required is being shared across the layers is ensured. Coming to the communication layer, it acts as an information bridge that helps in providing a communication between the sensing layer and the servicing layer. Sensing layer is at the second level and the service layer is at the fourth level. It acts as an interface between these two layers. Right? That's what it is being represented as an information bridge. Coming to the next fourth layer, that is service layer. This layer helps in performing the activities that are required by the client. What else the client is being requesting? It acts as a it propagates or it helps in communicating these connect data between the other layers. Right. Then infrastructure layer. This layer creates the service-oriented architecture technologies like GIS mapping or cloud computing, big data, cognitive computing, storage facilities, where based on the infrastructure, whenever the infrastructure is being enhanced or shrunken or based on the requirement of the user, then this infrastructure is being expanded or shrunken. Right. Coming to the IoT architecture layers, that is roles and functional responsibilities and functions of six-layer architecture. Six-layer architecture. The six layers, the first one is focus layer. This helps in identifying the nodes, where the different nodes or where the different sensors are there. Accordingly, the data has to be collected. Coming to the second layer is cognitions layer. This is all about the sensing capability of the information, such as how the sensors are, how the activators are there, what is its capacity, how the monitoring has to be done by a single node or multiple nodes, how it has to be, how the capability or the capacity of the sensors to be or there, right? This all depends or deals with the cognitions layer. Coming to the third one, transmission layer. Its main feature is to transmit the sensed data from the cognitions layer. From the earlier layer, it collects the data and passes to the higher levels. Then fourth layer, that is application layer. It has a special feature of collecting and categorizing the information and as per the requirements in the application zone. It segregates, it collects, right? As the name indicates, application layer, it's a special feature of collecting and categorizing what else the data has to be done or pushed up. Right? The next, the fifth one is infrastructure layer. As the name indicates, the infrastructure, whether it has to be enhanced or what else the infrastructure is required for the concerned application. Either it has to be extended, whether the data analytics has to be done or the data storage has to be improved or massive computing is required, that all those features are categorized or analyzed here. Coming to the next, the last sixth layer, that is competence business layer. This layer allows the assessment of the proposed IoT system. The complete assessment is being undertaken or taken care by this layer in terms of business network analysis, especially the business and the profit models in a user-friendly manner. Coming to the next higher level, that is 7 layers of IoT architecture. Basic IoT architecture is 3 only. Based on the environment, it goes on subdividing or categorized into subsequent levels. Now the maximum level is the 7 layers of IoT, that is application. As said earlier, it's responsible for collecting the information. Application support and management layer, that is, it governs the entire all the layers or the integration of layers, such that this layer allows to have complete managerial control and security over the IoT system. As the name indicates, application support and management layer. Coming to the third layer, that is service layers, it helps in performing the activities such as what based on the client request, what else has to be done, whether it is being processed or serviced or not, will be entirely monitored by this layer named as service layer. Coming to the communication layer, as the name represents, it is responsible for communicating data between the higher and the lower layers. Okay? It acts as an information bridge that helps in providing a communication link between sensing and the service layers, and the upper layers and the lower levels of layers. Network layer, it is responsible for transmitting and processing the data. Whereas hardware layer, it has to integrate all the hardware components together for proper implementation, such that it is being monitored by the application and support management layers. Whereas the environment layer, where the sensors are being placed at different environments or what we call it as where the sensors are being deployed. That is, this layer allows the possibility to detect the objects or places that are under observation. Right, This has the capability of observing the physical moving objects such as either humans, cars, or environmental factors such as temperature or humidity. Either standstill location or even the object might be moving. That's what the humans or cars. From the environment, the data has to be collected. For example, you are considering autonomous cars. Whenever the car is being driven the road, it has to collect the live objects or interactions or intrusions that comes across the roads, right? When this is one example, whenever the car is moving, the vehicle is moving, autonomous vehicles are there, that it is being moving, it has to collect all the data and from the surroundings, from the environment. It, according to that, it has to process. That's point number one. If it is not the vehicle or the if it the directly the object represents the sensors which is deployed at agricultural plot, either it might be a temperature sensor or humidity sensor. From those environment, it has to detect from various objects, that is various nodes, right? Collectively put together, coming to the last layer, that is fog based or cloud based architecture. Cloud based architecture comprises of layer, application layer and network layer. In between cloud layer will be there. Whereas in the cloud layer, what else activity has to be taken care is the monitoring layer, pre-processing layer, storage layer, and security layer. All these together formed in a fog layer. That's what the segregation goes. That's how the segregation goes with respect to the cloud layer and the fog layer. In fog layer, what else functionality is taken care by the cloud layer is categorized into individual sub-processing. That is monitoring layer, pre-processing, storage, and also as well as security to provide more authenticated transfer of data between the layers or between the devices. IoT improved layer architecture. What layer we have seen right now, right? That's all the layers. What is the ways in which the layer can be improved? The layer can be improved. Coming to the application layer, most the arrow is there. The application layer, the application support and management layer, service layer, commission layer, network layer, hardware support or hardware layer, and at last environment layer. In all those layers, IoT application, what is the various components or what else the various criteria has to be sorted out. With respect to application support and management, UIS has to be their quality of service, business process, trust, or the device manager, process modeling, authorization, exchange of data, or the management, identity management. These are factors to be governed with respect to application support and management layer. Coming to the service layer, service storage, then virtual entity, IoT services, service connection, virtual environment, IoT service resolutions, then even IoT service overall monitoring has to be taken there with respect to the service layer. Coming to communication layer, the flow and stability and the reliability, energy optimization and quality of service. Coming to the next layer, network layer, what is the way that it can be communicated to the higher levels and the lower levels of layers? This through gateways, routing and addressing, network capabilities, transport capability, error detection, recovery, and also as well as correction, right? Coming to the hardware layer, where directly sensors are deployed to collect the data, to generate the data, to process the data. Sensors and other sensors of hardware used for detection. The environment layer includes objects to be detected and placed to be observed. These are the various ways in which all the layers, the responsibilities are being categorized. One best example is being given here. One best example for all the layers. These are the layers. Application layer. See, in the earlier slide, these are the layers now. 1, 2, 3, 4, 5, 6, 7 layers there. From application layer to the environment layer. The same thing is being done. Yeah. Application layer, application support and management, service, communication, network, hardware, and environment. See, the users are being activated at the application domain. Whereas application support and management, where quality of service, the manager, the authorization, identity will be done with respect to application support and management. Whereas with respect to service, what else various services can extend or services are being extended, either monitoring the instances, resource allocation, analytics and visualize IoT database. Coming to the communication, through either the web portal or else the flow control, reliability, network, either the LAN, wired or wireless, right? Then coming to the hardware, the concerned hardware and the environment. For example, if I want to track a particular device being ordered online, or the device management, or else if I want to monitor a particular temperature in my farm, in my field, or I am going for a week autonomous vehicles, driverless vehicle cars, driverless cars, or unmanned aerial vehicles. We call it as the drones, right? Whatever the object or objective is to go beyond. Whenever we are accessing the collecting the trying to get the data from the field, and it has to be processed. After processing, you're making it, storing it, and with that storage, you are going for getting by applying analytics to it. You are going for extracting the data or knowledge from the data. That is what we said to be as insight about the data. All those scenarios, these sort of plays a major role. That is the model of end-to-end interaction between the various layers and improved layer of IoT architecture. This is what how it goes from the application layer to the perception layer, from the application layer to the network layer, security, processing, observing, and perception. This is how the with application layer means either it deals with the smart homes or e-healthcare or transportation. Coming to the network layer, wireless networks are wired. Whereas with respect to security, encryption or decryption with much more hash encryptions. Processing layer, data processing or extract data, useful data or unwanted data are either for pre-processing. Before processing, we'll be going with pre-processing to work with null values or very basic operations something, or after the processing, post-processing will be taking care, right? For observer layer, we'll go with authentication, whereas perception layer deals with Bluetooth, WSN, or RFID, right? The security and challenges in IoT. Security and challenges in IoT. The main challenges associated with the development of IoT are first and foremost thing is heterogeneity of IoT data streams. Much more heterogeneity means much more data streams we need to collectively together and we need to process it. The second, varying data quality. Much more data with a noise and with incomplete. How to process it? How to process or how to deal with this? Then real-time nature of IoT data sets. IoT streams feature high velocity or a huge data is there with much more vastity of applications. From much more applications, we will be getting the data with high velocity, huge demand, or much more data will be there. How to process it? Coming to the time and the location dependency for IoT streams, the time is very, very, very important. For example, as already stated, one example we said for watering or delayed watering for a farm might be for 1 hour it will be acceptable, or 1 hour to 2 hour or maximum of half a day might be acceptable. That too, to some beyond extent we can't go even for half a day also. Whereas that half a day or 1 day might be to some extent it might be acceptable with respect to watering the agriculture. Whereas coming to the real-time scenarios with respect to the life of human being, even delaying half a minute or even 1 second or 2 seconds, it's very hard to get rid of a human life. Then we should be very keen managing the time and the location dependencies, right? For example, biochips are which are kept in the hand or which kept in the body, human body. It senses the data, either the blood pressure or even the sugar level or BP. All the things are being monitored and stored in the server, such that the human being which is being affected monitored hours together or days together, so that the human being life is being saved. Whereas the time precision is much more very important there. Whereas the privacy and security, the data, the privacy and security plays a much more major role. That is, the data has to be kept very securely such that only the authorized users or authorized intended persons can alone access it, right? Then data bias, as in the majority of data mining problems, IoT data can lead to biased processing, and hence thorough understanding and scrutiny of both the training and data set is mandatory or becomes mandatory. Right? Implementation challenges, IoT implementation challenges and solutions. As already we just saw it, right? These are the challenges, securities and challenges. The same is being represented in other form, right? If I want to go for implementing that, then what is the challenges and the corresponding solution? The first and foremost thing is security becomes, because the enforcing or ensuring the security is a very, very, very major problem. It has to be ensured without any other compromise. Second one is the interoperability and standards, because as one example we said, right, we are good click to the market either through online or offline mode. You are just purchasing a USB mouse or USB keyboard or else a very simple USB based webcam. You are purchasing it and you are just upon fixing or connecting to the CPU directly it starts working, right? So not only this, what else the data best an example I am sharing this one, but as the same thing has to be done with all the data storages and data what is the sensors being used or deployed for gathering the data from the IoT systems, that is interoperability and the standards, the technology-wise infrastructure, that is such as smart buildings, smart homes, smart cities, smart grids, smart intelligent transportation systems, and ubiquitous healthcare, to name a few. Just technology-wise, it is not all place stating that you can't represent that there is no place or there is a place where IoT cannot be deployed. No, nothing. Whereas the workforce, it is challenging to change the mentality of the current workforce. It is to get the trained personalities in the current domain where it is moving from the day by day. We are getting the advancements, right? The high investment cost, initial cost, high cost incurred in developing or coming up or deploying this becomes much more costly than reasonable costs are recommended. Whereas even though based on the again comes into the picture, but based on the requirement and the scenario, we need to go with the concerned pricing. Then the energy, since it uses low power or very less power, the concerned devices also has to be monitored such that it has to be energized properly on time, right? Whereas we will come to the picture of charging our mobile phones, right? Very recently, even charging C cables came into the picture. Within 1 hour, we can able to charge up to 70% or 80%, so that the entire day is being energized for the mobile phones. That much challenging we are having. The same thing has to be. We cannot expect it for even all the devices which is deployed very remote. So in those scenarios, we need to take care. These are the challenging scenarios, that is privacy and data protection, power consumption, limited batteries, global misinformation systems, global cooperation, intelligent data analytics, quality of service. Right. Further reading, you can go with this. Or as already as I stated here, this book will be a very good beginner book for everyone else. That is Internet of Things, a hands-on approach, right, by A. Bug and Vijay. For further readings, you can go with this. Thank you. If you have any queries, we will discuss.
Participants, if you have any queries, kindly post it in chat box, or you can unmute yourself and ask the resource person.
Yes. Just now I'm going through the chat sessions. How the authorization is provided in IoT? Yes, authorization means, see, the two, what else the levels we saw it here now. Actually, coming to these levels, for every layer, this TCP and UDP already see here we saw it, right? Request response based on the client and the server. Based on the client request only, the server is responding based on the client. Where if the client is not up to the level, or if he seems that for every request and response or every data transfer, there will be an authentication. That too, based on the scenario, again it goes. The server won't be responding to all the clients, right? Then you can see here, even for this model also, publish and subscribe. Here, if there is no any need of authorization, directly you go with the publisher, publish and subscribe. All the data will be available. Who else is interested, they will be subscribing to the concerned one. Whereas if the two, it's much more secured constraints, you can go with this push-pull model. Whereas exclusive pair model is there for the client. During those scenarios, the client will be connected to the server, will be there. In this scenario, in this way, we can able to provide authorizations, right? What are the attributes checked? That's what I'm saying. Even the two completely, it is based on the environment and based on the scenario or based on the client. It's Nina. See here, for example, for a very basic example, I'll tell you with respect to the DTH connection. If you are having in the home, if you want to add a one channel or if you want to deactivate one channel from the registered mobile number, you can make a call, right? Either to add a channel or deactivate a channel. Likewise, with respect to here also, based on the scenarios, based on a scenario for a public scenario or a group, how authorized. That for a group authorization, that's what based on the here. That's what the same example I'm saying. Here with respect to one client is being shared. With respect to see for actually it should not be represented. For example, I'll tell you there is one group file is there, or you are trying to download a particular video from the YouTube. In those scenarios, you need not be a particular. You should have a Gmail account, right? In YouTube, directly you just go there from the channel. What else you are interested, you can subscribe yourself and you can download. Whereas if you want to upload a video, there comes into the picture the authorization. You need to have a Gmail account such that with that account you can upload. By in those scenarios, they will be going on adding the restrictions or authorization based on the requirement. For watching the YouTube videos, there is no any requirement of adding or having a Gmail account, right? These are the basic examples I'm sharing. Likewise, in the even the IoT scenarios or the domains where the data is being collected or where the data is being communicated, there the authorization is into the force or authorization plays a role, major role into it. Completely it is based on the scenario and the application where it is being deployed only. Right? Whether hope I have answered your query or still you could not do good means we'll come back to you there. It is purely completely based on the environment only, the scenario only, and the application what for it is being deployed. Right? Yes, thank you. Thank you. Any queries, ma'am? Sir? Thank you, participants. Thank you. Thank you for attending the session. And thank you once again for from my side. I want to represent heartfelt thanks to the ACT, VCET, and our college for granting me for attend or to present this session. Thank you.
So, shall we wind up?
Yes, ma'am.
Okay, sir. Thank you, sir. It was a treasured session for all of us. Hope all the participants clear the doubts. Your most exciting talk on IoT building blocks, protocols and technologies, security and challenges will be useful for every participant. It was really an exciting session. We are sure that all the participants would have attained a good knowledge on structure and architecture of IoT, levels of IoT, stages of IoT with the real-time scenarios like home automation, tracking package handling, and challenges and security, etc. Once again, we thank you for your valuable ideas, which will certainly improve our ideas on IoT with blockchain. We are eagerly looking forward for more such interaction in the years to come. Thank you, sir.
Thank you, madam. Thank you. At last, finally, last but not least, I want to thank ACT, the VCET, the management, the principal, HOD madam, the organizers of the program, and our college, our principal, our data, the management for giving me this wonderful opportunity to present on day 2 session on IoT, the building blocks, protocols, and technologies, security, and challenges. Thank you, participants.
Thank you, sir.
Okay,
Participants, you can join the afternoon session with the same link by 1:30 p.m. Thank you all.
madam. Shall I stop share the screen, ma'am?
Yes, sir.
Fine, madam. Thank you. Have
Thank
a
you,
good
sir.
one. Bye, ma'am.
Thank you, sir.